Starting at the neuromuscular junction, vesicles carrying ACH are released into the synapse. From there, ACH binds to the receptor.
At the receptors, the ACH allows electrical signals to travel along the sarcolemma that go towards the T-tubules. Then the ACH comes and breaks down the ACH on the receptor, allowing a new one to bind to it.
At the T-tubule, electrical signals running along the sarcolemma enter the T-tubule. This releases the voltage gates, which allows calcium to exit the sarcoplasmic reticulum.
The purple line represents the thin actin filament, and the red line represents the thick myosin filament, and the arrow points to the M line. Now this arrow is pointing to the Z disc, which is the region of the I band that only has actin filament, and this arrow is pointing to the H zone, which is the central region of the A band that only has the myosin filament and does not overlap at all with the actin. The A band is in between both of the Z discs and contains the entire myosin, part of the actin, and the H zone.
Zooming in, we see individual actin filament, represented by the green helix, as well as the tropomyosin, which is represented by the green line running along the actin, as well as the troponin, which is the red shapes that attach to the tropomyosin. As calcium, which was seen earlier leaving the sarcoplasmic reticulum, comes toward the area, it binds to troponin, which makes it change shape, represented by the triangles. This causes the tropomyosin to move out of the way, which is shown through the black dashed line. Next, with tropomyosin out of the way, the actin binding site is exposed to the myosin head, which is shown with the purple protrusion coming from the red myosin. From there, it can bind to the actin filament. Then, ADP and PI unbind from the myosin head, which triggers a movement known as the cross-bridge cycle that causes the head to pull the actin filament back. This motion is represented by the green arrows. After this is finished, ATP comes in to bind to the myosin head, which causes it to move back to its original position, and the process can repeat itself. This sliding of actin filament past the myosin without changing size is how muscle contraction works on the microscopic scale.